You know, a revolution is happening right now, and it's not in a factory or some high-tech lab. It's happening out in our fields. We're talking about the rise of the robot farmer, a technology that might just be the most important key to the future of our food.
It really all comes down to one massive, fundamental question, one that affects every single one of us. How are we actually going to feed everyone on a planet that's getting more and more crowded every day? The stakes really couldn't be any higher.
And just to put a number on it, here you go. The United Nations is projecting that by the year 2050, our world population is going to hit 9.7 billion people. That's more than 1.5 billion extra mouths to feed compared to today. That single number is the engine that's driving this incredible technological push in agriculture.
So yeah, this population boom is really setting the stage for what could be a major food crisis. The problem isn't just about growing more food. It's more like a perfect storm of having more demand and less labor.
Think about it. On one hand, the demand for food is absolutely skyrocketing. But on the other, the actual number of people working in agriculture is shrinking. In places like Japan, farmers are aging out, and in countries like the United States, there's a lot of uncertainty around the immigrant labor that the entire industry relies on. It really just boils down to this: more demand, less labor.
So, what do you do when you're faced with a challenge this enormous? Engineers are turning to a pretty radical solution: the rise of the robot farmer.
So what exactly is an agricultural robot or an agrobot? Well, to put it simply, it's pretty much any robot that's used in farming to either help out human workers or, in some cases, replace them for specific jobs. And we're not just talking about one type of machine here. We are seeing a huge variety of automation heading out to the farm. I mean, think about drones monitoring crops from the sky, little autonomous rovers checking the soil, and, of course, robotic arms that can carefully pick produce. Yeah, the farm of the future is going to look very, very different.
So where are these robots having the biggest impact right now? Well, the answer is in the automated harvest, which is easily one of the most labor-intensive parts of all of farming.
Take a look at this. It's a real apple-picking robot in action. And this job isn't about brute force. Picking an apple without bruising it takes a really delicate touch and super precise vision. You know, skills that have historically been incredibly difficult for a machine to get right.
But it is not just about picking fruit. The possibilities here are incredibly broad, covering pretty much every part of farming. For instance, there are robots being developed for super precise weed control, sometimes even using lasers. They're also handling seeding and planting and even spraying chemicals so accurately that it could reduce herbicide use by up to 90%. And it goes beyond the crops, too. They're being used for monitoring soil, the environment, and even livestock.
Okay, so all of this sounds amazing, right? But here's the reality check. Building a robot that works perfectly in the clean, predictable world of a laboratory is one thing, but building one that can handle the sheer chaos of a real farm, well, that's a whole other challenge. And the scale of this challenge is kind of shocking. Research has shown that a fruit-detecting robot using an advanced AI could identify fruit with perfect, 100% accuracy indoors. But the second you take that same robot out into direct sunlight, its accuracy plummets to just 69%. That is a massive drop in performance.
And right here you can see exactly why. On the left, that's the clean lab setup. The apples are totally visible against a plain background. It's easy. But on the right, that's the reality of an orchard. The fruit is half hidden by leaves, you've got shadows everywhere, and the light is changing constantly. For a computer, that's a visual nightmare. So at the end of the day, it's all these things. The unpredictable light, the deep shadows, and all that background noise from leaves and branches, they all team up to confuse the robot's vision. What our human brains can process in an instant becomes an incredibly complex problem for an algorithm to solve.
So, how do you fix a problem like that? You can't change the farm to fit the robot. You have to teach the robot to see the farm. And that has led to a major leap forward in the technology that powers these machines.
The early methods were pretty simple. A robot would just look for pixels of a certain color, like red for an apple. But as we've seen, that's super fragile. The new method, though, is much, much smarter. It uses deep learning models like YOLO, which stands for You Only Look Once. So instead of just seeing color, it's been trained on thousands of images to recognize what an apple actually looks like in all its different forms, kind of like how a human does.
So here's how it works under the hood. The AI looks at the image and draws what's called a bounding box around anything it thinks is the target object. It's not just seeing color anymore, it's recognizing shapes,
textures and context to say, yep, that's an apple, and then it calculates its exact position.
Okay, so the KEK is getting smarter, but there's one more huge hurdle: money. This quote from a report on an apple-picking robot says it all. Even if the robot works perfectly, right now it costs more to pick a kilo of apples with the robot than their target price. For this to actually work in the real world, it has to make economic sense.
But there is a clear path to getting there. That same report shows that the cost can be brought down by simply making the robots faster and more efficient. By upping the picking speed or just adding more arms to a single robot, they can get to where they need to be. It basically frames profitability not as a question of if, but as an engineering problem of when, and they're definitely working on solving it.
And all of this leaves us with this one final crucial question. As these machines get smarter, faster, and cheaper, what does the future of farming actually look like? Are we heading toward a world with no human farmers at all? A world where humans and robots work side by side? Or something else completely? The technology is moving fast, and we're going to have to find the answer very, very soon.